for CO2, you know, total number of valence electrons are 4 from carbon and 6 from each oxygen. So total valence electrons are 6, and total number of electrons required to complete their octets is 3 into 8, that is 24. So number of shared electrons equal to total electrons required to complete octet minus valence electron, that is 24 minus 16. So 8, that means shared pair is equal to number of shared electrons divided by 2, that is 4. So shared pairs are 4, and unshared electrons, that is equal to valence electrons minus shared electrons. So valence electrons are 16 and shared electrons are 8. So 8, so unshared electrons are divided by 2, that is 4. So 4 shared pairs and 4 unshared pairs, right? So best way to distribute around central atom is 2 2, but it can be 1 3 or 3 1. If there are 3 bond pairs, there is only 1 bond pair. If there are 1 bond pair, then there are 3 lone pairs. Here 2 2. In this case, so these are the structures for Lewis structures for CO2. Okay? Okay, no worries now, but next time please keep in mind that you should submit the assigned task. Okay? So this is for CO2. Okay? So Lewis structure for CO2 is this one. These are the Lewis structures of CO2. Now, formal charge. Say charge on the molecule, charge on the ion is charge as a whole on, means charge on the molecule on ion is sum of the apparent charges on individual atoms, right? Charge on the ion is actually the sum of the apparent charges on the individual atoms, and total sum of apparent charges on all the atoms in a molecule is equal to 0. So this is the funda behind the total charge. Now if we assign charge on each atom, that is called formal charge. It is not actual charge on the atom, but if we assign the charge on the basis of electrons, that is called as formal charge. That means formal charge is the charge on individual atom, okay, on the basis of covalent bonding. So formula for formal charge is formal charge on any atom is equal to valence electrons on each valence electron on atom, on that atom, minus number of unshared electrons minus half of number of shared electrons. So this is the formula to calculate formal charge on any atom. Let us take example of CO2, 1, 2 and 3, or you can write A, B and C. So formal charge on A atom, formal charge on atom A, oxygen atom. How many valence electrons are there? 6, minus unshared 2 minus half of shared. So how many shared electrons are? 6. Total shared electrons 6. 3 its own and 3 of carbon. Total 6. That means it is equal to 6 minus 2 minus 3. That is equal to plus 1. So formal charge on this carbon is plus 1. What about carbon? Formal charge on atom B. So valence electrons of carbon are 4 minus unshared 0 minus half of shared. So 1, 2, 3, 4. 4 bonds mean total 8 electrons. So 4 minus 4 means 0. So formal charge on this is 0. What about this? Formal charge on atom C. Yes, tell me. So 6 valence electrons. Total shared electrons, sorry, unshared electrons 6 minus half of 2. So it is minus 1. So formal charge on C is minus 1. Plus 1, 0 and minus 1. Okay? Formal charge on each atom in ozone. Formal charge on each oxygen atom in ozone. Okay, so say in ozone its structure is O double bond single bond. How do we know that ozone is like this? You know, in ozone valence electrons are 3 into 6, 18. Total electrons required to complete their octet 24. So shared electrons 24 minus 18 means 6. So shared pairs 6 by 2 means 3. So 3 shared pairs between 3 oxygens. So 2 1 or 1 2. And unshared electrons, valence electrons minus shared electrons. So valence electrons are 18, shared electrons are 6. So 12. So unshared pairs equal to 12 by 2 means 6. So 3 shared pairs that we have arranged and 6 unshared. So say in this case, total 2 plus 2, 4 electrons are used. It has 4 electrons. So 4 more are required to complete its octet. This oxygen 2, 4, 6. 6 electrons it has. So 2 more are required. 2 it has. So 6 more are required to complete its octet. So in this way, 1, 2, 3, 4, 5, 6. So 6 unshared pairs. That's it. So take it as A, B and C. So what is formal charge on oxygen A? Formal charge on oxygen B. Formal charge on oxygen C. 6 electrons minus 2 plus 2 unshared 4 minus shared 4. So 6 minus 6 means 0. So on oxygen A there is 0 formal charge. Oxygen B 6 minus 1, 2, 3. 6 minus half of 2, that is minus 1. 6 minus 6, sorry. Yes, 6 minus 2 minus half of, for B 6 minus 2 unshared and 1, 2, 3, 6 shared. So it is plus 1 actually. Plus 1 on B. Okay. For C 6 minus 6 minus half of 2. So minus 1. So for C it is minus 1. For B it is plus 1. For A it is 0. So formal charge is equal to charge assigned to the individual atoms in a molecule or ion. It is the charge assigned on each atom in the molecule or ion. Okay. Now, octet rule that we have already done, octet rule and its limitations. This is also very important question. What is octet rule and what are its limitations? So octet rule is, what is octet rule? That atoms can combine either by sharing of electrons or by transference of electrons in order to complete their octets, in order to acquire noble gas configuration. Okay, so that is called octet rule that we have already discussed. What is that? Atoms can combine either by sharing of electrons or by transference of electrons in order to complete their octets, in order to have 8 electrons in their valence shell, or in order to have electronic configuration, have noble gas configuration. So that is called octet rule. Now what are the limitations? Actually, according to octet rule, those atoms which has complete, those molecules in which each atom has complete octet of electron are more stable. It is supposed to be, okay, but there are many molecules which are stable, but they have either less than 8 electrons or more than 8 electrons, or sometimes odd number of electrons. Even then they are stable. So they are the limitations of octet rule. Okay, so first is what limitation. I am discussing about limitations because octet rule we have already covered, okay, in previous lectures. So first limitation is electron deficient molecules. Electron deficient molecules. So those molecules which are stable, but in these molecules central atom has less than 8 electrons, they are called electron deficient molecules. Few molecules which are stable but their central atom has less than 8 electrons in their valence shell are called electron deficient molecules. For example, lithium chloride. You know, lithium has one valence electron and chlorine need one more electron to complete its octet. So lithium chloride is a stable molecule, but lithium has only 2 electrons in their valence, in its valence shell. Okay, beryllium chloride. Beryllium chloride. In beryllium chloride, beryllium has 4 electrons in its valence shell to its own, and 2 are shared with 2 chlorines. So it has only 4 electrons, but BeCl2 is stable. Then AlCl3. In AlCl3, aluminium has 3 valence electrons. It share electron with chlorine. So aluminium okay. So in this aluminium there are 6 electrons. In lithium chloride, lithium has 2 electrons only. In beryllium chloride, beryllium has 4 electrons only. In AlCl3, aluminium has 6 electrons only, but they are stable. Octet is not complete, but even then they are stable. Okay, so this is limitation of octet rule. Beta, we are talking about valence shell 1s2, 2s1. So in the valence shell it has only 1 electron. So it is shared, say, less than 8 electrons in their valence shell. We are not talking about core electrons. So this is the first limitation, that there are electron deficient molecules. They are stable. Okay. though they have tendency to gain electrons, okay, but they exist as lithium chloride, beryllium chloride, aluminum chloride. BeCl2 beta, beryllium has 2 valence electrons. So 2 electrons are shared with one with each chlorine. That's it. Okay, I got your point. You have 2s2, okay? 2p is vacant. This is ground state, okay? So beryllium in excited state, one of the electrons shift from 2s to 2p. So these 2 electrons form bond with chlorine. It is like this. Okay? Ralam, got it? Actually it is next topic, but I think you have in mind that it has a pair of electron. And how can it be formed a bond? I think so. You have this thing in mind. So what happened? One of the electron from 2s is shifted to 2p. So it has 2 unpaired electrons. Okay? Okay, done. Same is the case with aluminium. Okay. Now, second point. Second is odd electron molecules. Odd electron molecules. Molecules having no doubt less than 8 electrons, but in odd numbers. Okay? For example, nitric oxide, NO. So this molecule NO, it can be written like this or this. So this is an odd electron molecule. Okay, nitrogen has 2, 4, 6, 7. 7 valence electrons. See, 2, 4, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. So means it cannot be like that. So it is actually 3 electron bond, but it is like 2 electron belongs to oxygen and 1 electron belongs to nitrogen. It is half electron bond actually. 3 electron bond has half bond order. Bond order means how many bonds? So it has 2.5. 1, 2 and 2 and 0.5. 2.5 bond order. Okay. But anyhow, that is not our case. We are talking about that this is odd electron molecule, but it exists. NO does exist in the atmosphere. Okay. Then NO2. NO2 and double bond O, single bond NO2 is like this. Here again, nitrogen has odd number of electrons. So NO2, this molecule does exist. Okay, and they have no complete octet of electrons. Here nitrogen 2, 4, 6, 7. There are 7 electrons around nitrogen. in nitric oxide as well as NO2, nitrogen dioxide. Okay, so odd electron molecule also exist, which is the limitation of octet rule. Means octet rule is not followed by these molecules. Okay, then third one, expanded octet. Molecules with expanded octet means they have more than 8 electrons. Okay, for example, PCl5, SF6, IF7. There are so many more, but we are talking about that these type of atoms. For example, in PCl5, phosphorus has 5 valence electrons. So they form 5 bonds. Why structure is like this, that I will explain in the next lecture. PCl5, so around phosphorus there are 10 electrons, right? SF6, sulfur is surrounded by 6 fluorines, so there are 12 electrons. Around sulfur. IF7, so there are 14 electrons around iodine. 7 its own and 7 are shared with 7 fluorines. Sulfur has 6 electrons, valence electrons, 6 are shared with fluorines, so total 12 electrons. So they have more than 8 electrons in their valence shell, but they are stable and they do exist. Okay, so this is the third category of molecules which do not follow the octet rule. Then fourth limitation is shape of molecules. Like in PCl5, SF6, IF7, I have drawn some particular shapes. So these shapes were not explained by octet rule. Shapes and arrangement of electron pairs were not explained by octet rule, and even their energies as well. What is the energy of the molecules? What is the shape of the molecules? What is the arrangement of electron pairs? That is not explained by octet rule. Fifth one. Compounds of noble gases. This is the big jerk to the octet rule. Why is it so? Because octet rule is based on the stability of noble gases. That atoms can combine by sharing of electrons, by transfer of electrons to have noble gas configuration. So now noble gases also form bond. So means octet rule is nowhere then. But even then, in spite of all these limitations, octet rule is followed by most of the molecules. In the covalent molecules, in most of the covalent molecules, octet rule is followed. And we can explain their structure, we can explain the bonding, covalent bonding by using octet rule. Okay. So compounds of noble gases as xenon can form xenon as well as krypton, but let us take xenon. For example, as xenon can form compounds with fluorine and oxygen. So that is the biggest jerk to the, or I think biggest limitation to the octet rule. For example, HCF2, HCF4, HCF6, HCO3, HCO4, HCO2, F2, HCOF4, and many more. Okay, so this is also the limitation of octet rule. And you know, hydrogen, compounds of hydrogen is always limitation to the octet rule. Compounds involving hydrogen, H in their compounds, in their compound और मॉलिक्यूल की compounds involving hydrogen atom, hydrogen as H as their one of the atoms. For example, HCl, H2O, NH3. That's all. Okay. So these are all limitations of the octet rule. चलो आज यहीं तक करते हैं. आप लास्ट ये करो, राइट फॉर्मल चार्ज on each atom in carbonate ion. Okay, carbonate में it is like this. There are 4 pairs actually that we have already discussed. So now and sum of the formal charge is equal to charge on the ion. So A oxygen, B oxygen, C oxygen and D carbon. So what is formal charge on oxygen A? Valence electrons are 6. Oxygen has 6 valence electrons minus unshared electrons. 1, 2, 3, 4, 5, 6. 6 unshared minus half of shared. So shared electrons are 2. So total 6 minus 6, 0 means minus 1. On this oxygen, valence electrons are 6 minus unshared. 2 plus 2, 4. 4 unshared minus half of shared. So shared electrons are again 4. So 6 minus 4 minus 2, 0. And formal charge on oxygen C, that is same as A, because same number of electron pairs, unshared pair, same number of bond pairs, same number of valence electrons. Now formal charge on carbon D. So carbon has valence electrons 4 minus unshared 0. Very good. And shared 2 2, 4, 6, 8. That is 4 minus 4, that is 0. That's it. So this is all about formal charge and limitations of octet rule. Happy Ratri. Bye bye to all.